I'm the one in my zone. 다른 애들은 삐약. 저 취한 바보들 좀 봐. 이건 무슨 일이야? 그럴 필요 없어. 난 it's okay. I'm sorry. 가슴만 더 뜨겁게 지워버리지 널 부드럽게. We don't need nothing. Oh no.
I'm giving you my invitation. 아점에 pay attention. 궁금해나 비주얼 번역이 된 건 대전 밖으로 난리 났어. 어떡하면 축하는 나들 가는 우리 멀어. 취하지 않은 네가 밤만 우리 월어. 터지는 개성의 밤만 두드려버려.
지금 우린 마치 불도리야. 불도리야. 말리지 마. 말리지 마. 웃지 마. 진짜 마지막인데. Pop it away. Pop it away. 여기에 지금 붙어버릴 것 같은 취한 바보들 좀 봐. 이건 무슨 일이야? 모두 잘못 보고 있어. Oh no. 어찌 그게 진짜 멋이라고. 우린 필요가 없어. Oh no. Oh, oh.
너도 갖고 있잖아 너만의 뜨거운 배.
여기 불이야 저기 불이야 온 동네 전기가 불켜 춤추네. 여기 붙어라 저기 붙어라 온 동네 전기가 불이 붙을 때. Yeah 두루두루 뭐 여기도 make a fire like on my tail. Yeah yeah 시작 showtime and 지금 우리 마치 불놀이야. 불놀이야. 말리지 마. 말리지 마. 웃지 마. 진짜 마지막인데. Pop it away. Pop it away. 여기에 지금 붙어버릴 것 같은 알고 있잖아 지금 넌 네가 느끼고 있는 이 떨림을. 내 옆으로 와. 내 자리로 와. 우린 뜨겁기 위해서 어떤 것도 필요 없어.
높이 타올라라 번쩍.
지금 우린 마치 불놀이야. 불놀이야. 말리지 마. 말리지 마. 웃지 마. 진짜 마지막인데. Pop it away. Pop it away. 여기에 지금 붙어버릴 것 같은
Nothing but the truth.
If you don't call me,
Check this out, y'all. I don't want you back, don't call me. I keep saying next time and I'm saying you're alive.
깊어진 밤 집요하게 벨이 울려 It's your calling. 고집스럽고 지독하지 그게 바로 너 스티커.
넌 쉽게 포기 못해. 그 성질 버리지 못해.
온종일 내 이름만 수치해. 내 흔적들을 찾아 핥아대.
내 아침을 망치곤 해. 그 패턴은 뻔해. 관심 꺼줄래. I know where you came from.
그대는 나의 셔리 사라져 줄래 저리.
Don't think about calling.
넌 못 버티겠지 집착뿐이겠지 나처럼 잘한 사람 없을 거니까 너도 참 피곤했지 전부 꾸며 대니 머릿속 꽤나
어지러웠을 거야. 미쳤어 넌. You don't know you waste my time. 네가 봐 넌 최악이야. What I hate you call. 끝났어 너의 love. Don't worry now. 사랑하면 보내줘. Don't worry now.
계속 말하잖아 next time 넌 너서 eat your life. 네 사랑 난 이제 아니야. 지워 날 잊어버려 제발.
난 널 몰라. 손 위에 쳐.
네가 보여 trash 진짜 늦었다니까 널 믿지 않아 you know why 날 속였다는 걸 알아 속인 걸 알아 비극은 왜 사랑의 몫인데 슬픈 에픽 속그 끝을 보고 있네
넌 못 받겠지 집착뿐이겠지 나처럼 잘한
사람 없을 거니까 미쳤어 넌 You know you waste my time 네가 봐 넌 짜야 When I hit you come 갈랐어 너의 love Your love Don't worry now 사랑하면 보내줘 So bad Don't worry now
계속 말하잖아 next time은 없어 in your life 네 사랑 아끼지 않냐 지워 널 잊어버려 제발
난 널 몰라 손위에처럼 하지마
아직 같은 꿈 속에서 포기 못했니
I'll never pick up 지워버렸어 I'm gonna save my life
for the next call
Sorry, the number you have called has been disconnected 끝났어 love 사랑은 원인 now 사랑했다면 보내줘 When I hate you call 난 찾을 거야 love My love 더 아름다운 Don't worry now 지독했던 너와 나 So bad 잊을 수 있는 Don't worry now 계속 말하잖아 next time은 없어 in your life 네 사랑 아끼지 않냐 지워 날 잊어버려 제발 난 널 몰라 손 내게 전화하지마 사랑했어 사랑으로 인연했어 연인으로 이별 없이 영원할 줄 알았는데 사실 아직도 거짓말 같죠 활짝 웃으며 올 것만 같죠 아름다웠던 모습 그대로 이제 와서야 후회만 해요 웃는 게 예쁜 그대를 이해만 해줘 내가 바란 건 이게 아닌데 결국 이 지경이 꼬리진 나란 너 지켜주지도 못했지 너란 것 빨갛게 불타오르던 우리 모든 게 하얗게 쟤만 남았죠 사랑했어 사랑으로 인연했어 연인으로 아름다운 사랑 꽃을 피웠는데 웃음은 왜 울음이 돼 님에서 남이 돼버린 그때에 이별 없이 영원할 줄 알았는데 우리
내 꿈속에서도 멀어지는 너 아무것도 넌 할 수가 없죠 멈춰버려 소리쳐도 너네 때문에 사라지죠 yeah. 왜 네가 있을 때 자리가 했던 걸 그때 난 몰랐을까 왜 모든 것들을 잃고 난 후에 소중함을 알게 될까
결국 이 지경이 꼬리진 나란 놈 지켜주지도 못했지 너란 꽃 빨갛게 불타오르던 우리 모든 게 하얗게 쟤만 남았죠 사랑했어 사랑으로 인연했어 연인으로 아름다운 사랑 꽃을 피웠는데 웃음은 왜 울음이 돼 님에서 남이 돼버린 그때에 이별 없이 영원할 줄 알았는데 우리 왜 그때 마지막인 줄 알았다면 조금 더 네 모습을 담아뒀을 텐데 단 한 번도 사랑
나가 더러운 시선 신경 쓰지 마 미친 척 밟아 let's go on a ride Get on my bike let's go Get on my way 보여줄게 how I like it Get on my way It goes like vroom 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 Get on my way 고개를 들어 넓어 face Get on my way It goes like vroom 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 I'm getting higher You're tripping lower And when I say it's done It's freaking over And I write it You like it when I write it I write it My sweat dripping down my back I got ice decorating my neck Be the strongest thing, don't miss it Cause I'm the baddest queen I'm sicker than all them gossip and low-keys Don't bring me no fun Come on, I'll slay from tip of my tongue You wanna know and know what you like Sit back and watch me ride I'm up here, say yeah 따라와 faster, yeah Regret so slower 내 방식 그대로 짚고 나가 더러운 시선 신경 쓰지 마 미친 척 밟아 let's go on a ride Get on my bike, let's go Get on my way 보여줄게 how I like it Get on my way It goes like vroom 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 Get on my way 고개를 들어 넓어 face Get on my way It goes like vroom 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 I'm getting higher You're tripping lower And when I say it's done It's freaking over And I write it You like it when I write it I write it Oh, yeah Write it You know how I like it Write it You know how I like it 설렜던 그 눈빛 타오르는 공기 Again alright with me 벅차오른 순간 몸을 쓰게 다시 Together 1, 2, 3 Get on my way 보여줄게 how I like it Get on my way It goes like vroom 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 Get on my way 고개를 들어 넓어 face Get on my way It goes like vroom 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 I'm getting higher You're tripping lower And when I say it's done It's freaking over And I write it You like it when I write it I write it
Good morning. Can you guys hear me?
Yes, sir.
Yes, sir.
All right. Okay. Let me just fix my slides. Can you see my screen?
Yes, sir.
All right. Sige. Okay, good morning. The session is now is currently recording. So for your other classmates who will catch up, they could just refer to the recording. But the content I prepared today is actually, from a normal semester standpoint, I discussed this for 2 to 3 weeks. Okay, so we're going to discuss a little bit of the overview of data warehousing, which if you read on Canvas, that's basically it. I'll just try to give a summary, and then we'll focus on the dimensional modeling process, which is basically what you will be doing for the laboratory week 4 laboratory. And then we will also look at some data warehousing models for specific business processes. Okay. Yeah, that's basically it. So any questions, concerns before we start? Are all good? Okay, so again, let's try to catch up. All right, so from the to summarize the data warehousing aspect, okay, so I presented this chart. By the way, if you have any questions, feel free to raise it up on chat. So we have a record of the questions, and then I'll try to answer that at the end of the session if we still have time. All right. So now we have this diagram. I showed this also on one of the recordings I posted on Canvas. Basically, the point here is that we have these systems. We call these the systems of record. Basically, what they're doing is that they are recording transactions or anything that is happening in the organization. It could be the financial systems. It could be like this one, point of sales for the cashiering. Okay, they are recording what is happening on different processes. Okay, now all of these things. Okay, for example, in the case of point of sale systems, okay, they are located on different areas technically. So from a different branch A, branch B, based on city A, city B, and so on. So the idea here is to consolidate everything first before it can be analyzed. Okay, so when we consolidate them, I usually at the end of the day, they push all the data to the headquarters on a form of an operational data store. Okay, so technically in the operational data store, you have the raw form of the data. Okay, what it means there could be duplicates of data. If the providers of if each of the point of sale systems were designed differently, they might be capturing data differently as well. So the dates might not be aligned. There could be some typos on some product names. Maybe an apple in branch A is called product A, but the apple on branch B is called product number 1. Okay, so those misalignment could happen at this stage. Now, but the point here is just simply to dump all the data on the ODS, on the operational data store. So there's no further analysis that can be done at this stage, right? Now, so that it can be used for analysis, okay, it needs to be cleansed, it needs to be transformed before it gets pushed to the data warehouse. Okay, by the name itself, data warehouse, tambakan ng data, right? That process is what we call the ETL, okay, the extract, transform, and load process. It's not just on an ODS to data warehouse integration or connection. It can be from any source to any target, okay, as long as there needs to be moving of data from one system to another. That can be done using an ETL process. Okay, so what is an ETL process? By the name itself, you extract the data from the source, you transform them, okay, using specific business rules. Okay, so for example, kanina, product 1 should be product 1 na apple should be product and product A apple are the same. So they should be synchronized and be mentioned as apple, right? So that's one example of transformations that can be done using the ETL process. Okay, so you are syncing up all the misalignments from the data sources, right? And then it gets pushed or it gets loaded into the data warehouse. Now, in the data warehouse, ideally that's the standardized form already of the data. So even if you choose any branch, even if you choose any day, any sales, they speak the same language, meaning we will not be able to see any misalignment again. If we want to know the sales for all apples, for all branches, it will show up as apples for all branches. Okay, wala nang product 1, product A, product 1A, product apple with a capital A, wala nang ganung misalignment. Okay, everything is just apple on data warehouse. Now, it can be pushed into a smaller versions of a data warehouse. Okay, smaller versions, we mean there is somebody owning that specific system or that specific database, and those are what we call the data marts. Okay, the data marts could be specific to finance, specific to marketing, specific to operations. Okay, so they don't have the entire copy of data warehouse kasi tambakan nga naman yun. If I am the HR, I'm not really keen on seeing finance data, or marketing data doesn't really relate to me if I'm the HR person, right? So, but I need the HR data. So I need to have an HR data mart. Okay, so that's the point of it. You can focus the contents of a database using the form of a data mart. Okay, so again, the difference between data warehouse is usually owned or managed by the IT. Okay, but the ownership of the data and also the data mart falls under the business users. Okay, and both of them, okay, can be used for reporting analysis for your executives. Okay, Now that's the one I mentioned in Canvas recording. So this is more of a detailed diagram. Okay, so I talk the same thing. These are your systems of record. We see here the POS, the point of sales. It can also be the ERP for the financials, legacy systems, meaning old systems that are existing in the landscape, other systems or external data. If you have flat files, Excel files, CSV files, you can push that into an ETL tool, ETL job for transformation and cleansing, and then push it back to data warehouse. Okay, and then for the data warehouse, you could create data marts for specific business cases or business users, or you can push it directly to a different reporting. Okay, so the data warehouse itself can provide reports already. So the data mart is really just an option. Okay, it's really just an option. But of course, some business users, would want to own their data, would want to have, the liberty to navigate through their own data. That's why we will give them their own data mart system. Okay, but the point here is all the data is now synchronized. You have a single source of truth inside the enterprise data warehouse, right? So just to summarize again, operational systems, the point of sale systems is basically running the entire organization, or as the slide says, turn the wheels of the organization. That's how we could take orders. That's how we could sign up new customers. If there are complaints, we could log them there. We could also produce products using those systems. But on the other hand, the data warehouse is how we watch the engines to run, okay? How we watch the wheels of the organization. That's when we actually count the new orders. That's where we look at the reasons why customers sign up to our loyalty programs, or maybe what their complaints are. And also, from a planning perspective, this is what you'll be using if you want to see if the production can meet the upcoming demand. Okay, so operations, analytics side, okay, that's a two differentiation of it, right? Now, this is dimensional modeling, okay? So it refers to logical design of a data warehouse that aims for user understandability, query performance, and resilience to change, okay? User understandability because data warehousing activities, although the system itself is managed by the IT, the creation of the models, creation of reports are usually handled by the business users. And in reality, business users might or might not have the right technical expertise to deal with all the databases. So the dimensional modeling can, it's a middle ground for that specific scenario. Okay, in that sense, they can read data models, but also understand it in a set that they can understand it from a business standpoint. Okay, query performance. So comparing, if you're familiar with other relational modeling from the databases, those database modeling are designed to be able to capture as much data as possible. But again, on the other in the data warehousing side, what we want to be able to pull out as much data as possible. Okay, so the dimensional modeling helps on improving the query performance or that specific data pulling process. Okay, and also lastly is resilience to change. So if you've seen the characteristics of data warehouse recording, okay, it says there that the data warehouse is non-volatile because we want the data to be in the data warehouse to be fixed. Okay, so if you are the sales analyst and you saw that we performed well yesterday, okay, and then next week we check the same day today, we check the same day yesterday, and then now the sales performance is below the target. Okay, so what are you going to report now that you have different information? So that's a thing. So it has to be resilient to change. It doesn't change really that much. We just append all the data in a data warehouse. Okay, so now in dimensional modeling, we have two main tables that we talk about. One is the fact table. So it's the primary table. So it's usually placed at the center when you do the modeling. It is where the numerical performance measurements of the business are stored. Meaning, if we go back to your business ideas, this is where your metrics are stored. Okay, if you're measuring sales from a sales process, this is where it will be stored. If you're measuring, for example, if you're measuring number of clicks on your website or application, this is where it will be stored. Okay, so each row in a fact table represents a specific measure or a specific transaction. Okay, and most of the useful facts, okay, useful facts, okay, most of them, yeah, are numeric and additive because again, the idea here is to be able to aggregate all the data at different levels. So we want them to be additive at any categories, right? Which I'll explain later on. Now, to explain the numerics in the fact table, that is the purpose of the dimension table. We add some descriptors into those numbers. Okay, so for example, the sales is 10 pesos, for example. Okay, now that's 10 pesos what? Okay, it could be 10 pesos worth of 5 pieces of eggs. Kunwari, 5 pieces of eggs. So now that's a dimension, that's a product dimension. Okay, we now treat the 10 pesos as eggs. Or another one, okay, 10 pesos worth of purchase from Juan de la Cruz. Okay, that's now from a customer dimension. 10 pesos sales made by store A. That's a store dimension. Okay, or 10 pesos sales was made yesterday, on late by yesterday. March 5. Okay, that's now the time or date dimension. Okay, so as you can see, we are now describing that 10 pesos in terms of different aspect or different dimensions. Okay, so that's the purpose of dimension table. All right, so how can you actually make such kind of modeling? So we have the 4-step dimensional design process. One is, first, we want to have a focus on our model. So you would want to select a business process to model. Okay. Now we declare the grain or the detail, the level of detail that we want in the model. We choose what dimensions to include. And now lastly is we identify what facts are we including. Okay. Now for selecting a business process, that's basically just selecting what business process you want to record. If you want to if your metrics are directly related to sales, then we will be looking at sales process, okay, or order capturing, stock shipment, other examples of business processes, inventory, how stocks move in your warehouse, okay, and also from the accounting perspective, the general ledger is also a type of business process. Okay, so that's basically the first one. We want to have a focus. We want to have a subject. So we select a specific business process first. Okay. The next one is declaring granularity. Okay. So granularity is what you will usually hear when you go in the industry talking about business intelligence. Okay. That is specifying exactly what an individual fact table row represents. Okay. That's quite technical. But the point here is at what level of detail are we storing in this model? Okay, it could be, okay, let's say our data model captures up to hourly granularity, which means that if I look at the sales data at this model, I could see up to the hour level. Okay, another type of let's say your systems could only capture daily data, not hourly data, then that's the granularity of your model. You can only capture up to daily level of data. Okay. It answers the question, how do you describe a single row in a fact table? So for example, if I look at one row, okay, I can only see daily sales. I can only see hourly sales. Okay, that's the level of granularity. Okay. Examples. Okay, if you're looking at daily snapshot of inventory levels for each product in a warehouse, Okay, so the granularity here is that we could look at daily data. We could also look at each product and each store or location. Okay, so that's the granularity. Another one is example I mentioned earlier about the time granularity, hourly sales of each KFC store. Okay, so we can capture hourly sales, but not just hourly sales, but you can also capture um, uh, sales data per branch or per store. Okay, another one is monthly snapshot of each bank account. Okay, of each bank account. So now we cannot see hourly snapshot, but we can only see up to monthly level, monthly snapshot of each bank account in the in the company. Right. So now you could have uh, uh, a very granular data or data model. You could also have a very um, ano ba, very coarse, less granular data model. Okay, so what does that mean? Or what's the catch of using both? Okay, so let's say we use less granular data. We store monthly sales data. Okay, that's fine. I can still see what will be my sales performance for this year. Okay. I can also do maybe a little bit of seasonality analysis because at least I can define the seasonality by month, right? So it's Christmas is December. So rainy season is what? July, August. Okay, we can still see a little bit of detail, but that's it. We can only see a little bit of the information. We could be losing some information that might be existing at the quarter level or at the weekly or daily level. Okay, because our data only stores monthly level. However, okay, if we process that from a computing standpoint, we're actually consuming less resources. Okay, so you might have experienced it on your own laptops. If you have so many tabs on your Google Chrome, then good luck. Okay, you probably have closed some of them before it runs back to its original performance, right? So since we are dealing with less data here for a less granular model, there are less computing resources that are being utilized. Okay, now if we go more granular, okay, so if you look at the year data again, from a 12-month data, that it's technically 12 rows of data. Now we want to have daily sales. Okay, that's how much? 365 rows, one record of sale per day, and we're just talking about one branch. Okay, so now that's the amount of data that's existing in your fact table, and that will be consuming more computing resources than the monthly sales data. Okay, so that's the catch. If we go for less granular, okay, we're utilizing less computing resources, but we're losing some information. If we go too granular, okay, good. We can see a lot of information here, but our computing resources are at stake here. If we don't improve the bandwidth or the capacity of our computing resources, then we won't be able to extract these data as soon as possible. So it will again affect the query performance. All right. I hope that's clear. I hope it didn't go too technical on the granularity. Okay, so let's now move on to the dimensions part. Okay, when we talk about dimensions, earlier I mentioned that dimensions describe your facts or describe the numeric measures in your organization. And that's true. Okay. In this case, if we're choosing a dimension from a business process perspective, you could think of it as placing a color on a Rubik's Cube. Okay. I will put red on this side, or let's say I want to see this process from a customer standpoint. I want to see this process from from a branch standpoint. Again, for a data warehouse, okay, it has to be time variant. So a time dimension is necessary. So we need to include a time dimension. Okay, so examples again, date, we have date dimension, product dimension, 10 pesos sales for eggs, 10 pesos sales for bread. Okay, we also have customer. 5 pesos was bought by customer A, 10 pesos was bought by customer B, 5 pesos was bought by customer C. Okay, transaction type, which sales transactions were purchased using GCash, using mobile apps, using credit card, and so on. Okay, so now you might be hearing the term cube. Okay, so it's also in one of the videos. A cube is a multi-dimensional data structure. Okay, so that technically allows the fast analysis of data that is designed to aggregate huge amounts of data at a nearly instantaneous time. Okay, so that's the purpose of it. So we can view the facts at a different dimensions. Okay, so now let's go to facts, the last one. It answers the question, what are we measuring in this process? So again, if we're looking at the sales process, we are measuring, of course, sales revenue and quantity. Okay, that's usually the two things. You can also add more features like margin, because that's technically just cost minus revenue minus cost. Okay, you could also add more details, tax, inventory on hand. Okay, so you can add different facts from a sales process perspective alone. Okay, so the facts should be numeric. Okay, and also additive. Okay, because we want them to be we want them to aggregate at some level, but also we must understand that it must fit the grain or the granularity of the fact table. Okay, so for example, if you designed a fact table for a monthly sales data, okay, and you have daily data, that's easy. We could simply transform the daily data into different months and you could aggregate them. But if you have a model that is for hourly data, but your systems of record can only capture daily data, then there's no way for us to divide those daily data into different hours, right? So we couldn't just simply divide each daily by 12 because that means that's just the average sales per hour. Okay. So that's why your facts need to fit into the grain of your fact table, okay, on whatever you design. Okay, so that decision might come from what data can we actually store. Can we store daily data? Can we store hourly data? Do we have them? Okay, if yes, then good. We can leverage up to hourly level of granularity. If not, do we want to capture hourly data, or can we rely on the existing daily data? Okay, so those are some of the questions that you want to ask when you are designing data model. Okay, one thing that I didn't mention is that when talking about dimensional modeling, it could also help you with when it comes to creating reports, right? So when you want to tell a story about your data, okay, with this dimensional modeling process, you could actually trace back what needs to be done in order to create such report. Okay, so for example here, let's say we want this insight. Okay, Juan de la Cruz bought 2 boxes of Chucky milk for 150 pesos last March 1, 2021, 4:19 p.m. at 7-Eleven Ateneo branch using GCash. Okay, that's an insight. That's technically an insight that you can share to, let's say, the sales managers or to maybe not the executives because it's specific to a customer. Okay, but maybe we could just group them. Let's say 18 to 23 years old bought 2 boxes, blah blah blah. Okay, but for now let's focus on this one. Okay, now we could extract some of the insights from here. Okay, I will highlight some of the phrases. Okay, parts of this sentence. We have this what we call 7 W's of data warehouse design. Okay, and in this slide, I forgot to put the why. Okay, but let's use these question points first. Okay, so the who, okay, it refers to the red, which is Juan de la Cruz. What refers to Chucky milk. Okay, when refers to March 1. Where 7-Eleven Ateneo branch. How GCash. Okay, so these things actually refer to the dimension tables that you want to include in your reporting story. Okay, So now, for example, if you were asked to create a sales report and they want to see, I want it, I want the sales report uh, trend against date, and I want to see it per product, per location. Now you have an idea what dimensions to put. You would need a time dimension, you need the product dimension, and you need the location dimension. Okay, so or let's say, hey, I want to see the customer attrition rate per branch, but I don't. I just want the level today. Okay, then you don't really need the time dimension. You just need the month, ano ba? Customer attrition for each branch, okay? Then you can just put location dimension on your report. Okay, so in that sense, you can design your reports accordingly based on what you want to tell. Okay. Now the last one is why. Okay, and that's usually if you don't capture that directly from the systems, that's what you will actually predict using predictive analytics. So that's the last one here in the 7Ws. Okay, now let's look at some examples, okay, of data warehousing models. Could you please at least give in chat if you kind of understand the story behind this, or maybe on microphone? If I'm showing you this, what do you think does it mean, or what does it say? What type of information can we get from this model? Anyone would like to try?
You can get the the date when the product was purchased and the store dimension where it was purchased and what kind of product it is in the
Mhm.
product dimension. And promotion, I guess, kung may discount. And
Okay.
as for the POS, yeah, yun yung sales amount. You can get the data from the POS.
All right, that's right. So you can. This is technically, yeah, as the title says, this is technically an example model for a sales process, right? So you could capture the sales transactions in the fact table. Okay, this is where usually the details will fall in. You can capture the sales quantity, sales amount, cost amount, and also profit. Basically, that's just sales minus cost. Okay, you can capture that, and then you can also describe that using the date dimension, using the store dimension, product dimension, or promotion. As you mentioned, if there are any campaigns, discounts, coupons, or loyalty programs, it also falls under the promotion dimension. Okay. Yeah, that's basically it. So again, the purpose of this one is for understandability. Okay, compared to other relational models, uh, which are focused on designing, being able to capture as much data as possible. Okay, so like, yeah, for the question, from the question of Miguel, okay, is different from a relational diagram. It's actually a type of relational diagram, but again, this is focused on aggregation of data rather than capturing data. Okay, so before you might have experienced doing the different ERDs and the entity relationship diagrams. Okay, when you design them with software development at the back of your mind, okay, then you want to design it that in such a way that it can capture as much data as quickly as possible. In this case, this dimensional modeling, we are modeling for um, pulling out the data or pushing out the data out of the systems. Okay, so that's the two main differences. And again, as you can see here, it's much easier to understand. This diagram is much easier to understand from a business standpoint. So if a business user looks at this, okay, I get it. We have the transactions in the middle, and I can use the different data around it to describe the data that is captured. Okay, now let's look at each of the dimensions one by one. Okay, for example, one thing is about a date dimension. In the date dimension, okay, it might not be as obvious, but the dates need to be defined in the system. Okay, What does 1/1/21 mean? Okay, that means January 1, 2021. And it's this day of the week, it's this month, it's this year. Okay. For some companies, they would have a different calendar system in their accounting books. That is the fiscal calendar. Like I know one company which starts their calendar year, they start their fiscal year at September, while most companies naman would start their fiscal year at January, at calendar year. Okay, so that means, okay, for example, from an accounting perspective, our day one, okay, should be the day one of the fiscal calendar. Okay, so if our calendar starts at September, the day one is actually September 1, not January 1. Okay, so those definition can be stored here in the date dimension. Also, if you want to indicate holidays, weekdays, promotional campaigns, you can also tag it here in the date dimension. Okay, specifically for the Philippine scenario, we usually paydays were also tagged. Okay, the 1530. Okay, that's also tagged here in a date dimension. Usually for the date dimension, because of the different systems right now, the producing date dimension is already automatic. Okay, at a single click, when you create date dimension in that system, it will also ask you when does your fiscal calendar start, or do you actually have a fiscal calendar? Because if not, it will rely on the calendar, on the actual calendar year. Okay, so the process is pretty much automatic already for most of the data warehouse providers. Okay. The next one is product dimension. It could contain a lot of information about the product. So earlier we have boxes of Chucky. Okay, that unit of measurement can be stored in the product dimension. Okay, in the product dimension, we can also discuss some hierarchy. Okay, so when we talk about milk, okay, it's not just one type of milk. It can talk about Chucky, it can talk about Selecta, Magnolia, and so on. And that milk could ramp up into a bigger category, which is consumables. Okay, that's an example. So if I'm the sales director for this branch, I want to know how my consumables are performing, then all of the products and brands under the consumables category will ramp up into that bigger category. Okay, that's the point of having a hierarchy such as this one. Okay, now for example, we have a product description, these different products. These are the brand descriptions, Bakewell, Fluffy, the category description. So these three fall under bread. Okay. Product number 4, fat-free mini cinnamon rolls, fall under sweetened bread. The rest fall under frozen desserts. Okay. And then it ramps up again into a bigger department description. Okay. These 4 breads, the bread and the sweetened bread, fall under the bakery department. The frozen desserts fall under the frozen foods department. Okay. So now if I want to see, let's say, all the bakery sales, it will give me all the data from these 3 bread and this 1 sweetened bread, and the brand doesn't matter. But also, if I'm a retailer, okay, I need to send reports to my suppliers. I need to send reports to P&G, to Selecta, to Magnolia, to Nestle. Okay. I can't send Nestle the data of ano ba competitor nila? Nabisco. Okay, for example. I can't send the Coca-Cola data to Pepsi, right? So in that sense, I will only look at the brand level before I send the data to them. Okay, so the hierarchy is there. I can simply, slice or drill down through the different departments and brands. Okay, na advanced ko pala yung discussion on drill down. Okay, so for example, from the bakery foods and frozen foods, this is the total sales dollar amount and quantity. If I drill down to brand description, it will split the department figures into these different brands. Okay, it will divide the $12,331 into these figures. Okay, now let's say from an analyst standpoint, I'm not a I'm not a brand analyst. I am a nutrition analyst. Maybe may ganung role. And I want to understand how our customers um, are purchasing when it comes to fat content. Then I can simply change the drill down. Instead of having brand, I can change it to fat content. And it will give me a breakdown of the different sales for each of the fat content categories. Okay, the non-fat, reduced fat, regular fat, and so on. Okay, so if you have encountered pivot tables before, this specific process might look similar because that is yet the same concept that is being applied on the pivot tables. Okay. Now let's look at store dimension. Usually for stores, of course, we have the names, address, manager.
I can't hear you. What's going on?
Edgar, can't you hear me?
Hello?
Hello? Edgar, can you hear me? Can you guys hear me?
Hi, I hear you now.
Okay. All good?
Yes, sir. We can hear you.
Okay. All right. Okay. Store dimension. Anything about the store? Address, name, country, city. Some store data can also store. Ang daming store, no? Some store dimension can also store, let's say, maps or floor measurements. Okay, it depends really on the level of detail that you can get or that you can store in this case. Okay, because some analysis would look at revenue per square meters, cost per square meters. So they will rely on these different dimensions to produce those kinds of reports. Excuse me. And lastly, promotion dimension. From a marketing standpoint, this is also necessary. If I want to see how my ads are performing or how my campaign is performing, we would want to attach the promotion dimension to the sales as well. Okay, same process. We have different dimensions here: ad type, display type, coupon type, ad media name, who's the provider, and then it's tagged to each sales transaction. All right. So I hope that gives clarity on the concept of dimensional modeling. There are some issues or comfort zones in dimensional modeling. One of them is snowflake schema. Okay? Snowflake schema talks about when your dimensions will have further dimensions. Okay. For example, here, okay, the product dimension is split into brand and category, which at some point could make sense, especially if we want to manage each of the dimension tables separately. Okay, we want to, let's say, we don't want to repeat all the data in the product. Don't want to repeat all the data in category. So we want to place them on a separate dimension table. Okay, so that's one good thing about normalizing the model or splitting the model into different tables. But again, if you put it that way, you are actually storing so much data already in the data warehouse. And if one looks at it, it's the simplicity is reducing. Okay, you can see like a spider web or a blood web of tables in one view. So for a business person, that can be something problematic. Because, for example, here at the bottom, sales transaction fact, it goes to product dimension, and then it splits down to brand dimension, package type, storage type, and then it splits to category, department. I mean, if I'm looking at this, I don't really need some of these details. Why don't we just push it down to product dimension? So now you have to make that decision when designing data warehouse. So whether to go for Snowflake or to remain in star schema, okay, that really depends on the business requirement. Okay. Yeah. But just remember again, ease of use and performance is the goal of modeling here. Now the second one is centipede schema. Like enjoy ka. Ooh, we can get so much detail just by looking at product and campaign dimension. Why don't we add more dimensions? Okay, let's add operations dimensions. Let's add inventory dimensions. Let's put it here, everything. Okay, now we have too many dimensions. We capture so much data, but we don't actually need a lot of dimensions when we just when we extract simply daily sales data. Okay, so not everything is needed again. Okay, so that's the point here. So you might some people, na-enjoy nila mag-design and they started putting everything inside one model, whereas you could actually use a different model to talk about something else, or talk about a different process, talk about a different subject. Okay. The next one we'll talk about inventory process. Okay, let's just skip this business process. Okay, so we can trigger the inventory process first from the sales process, from order to cash. Okay, if the salesperson wants to check whether there is still stock or inventory of a specific product before it gets sold. Okay, now the other one, it can be triggered from the manufacturing side. If I'm the manufacturing team, I want to know first if what stock needs to be replenished so that I can fulfill them. I can replace them, right? So it will trigger the inventory process again. Okay, so when we talk about inventory process, we are talking about different data models. Okay, so these are the three different inventory models. One is the periodic snapshot. The second one is transactions. The third one is accumulating snapshot. The transaction model is similar to our sales transaction. Okay, basically how much it captures the impact on the inventory transactions, but in this case, using financial value. So we can simply aggregate everything on different dimensions. Okay, the first one is periodic snapshot. It stores the current state of inventory data at a regular interval of time. So for example, if you are the store manager, at the beginning of a day, you need to have the beginning inventory. So you print out this report, this periodic snapshot, so that you can see what is your beginning inventory, and then you start counting the products in the store. Okay, that's a snapshot. At the end of the day, after all the purchases have been done, okay, you would want to have an ending snapshot, an ending inventory report, so that again you can count again the products inside the store at the end of the day. So that in that case, we are using periodic snapshot models. Okay, this is the data that you have there, and the granularity, quantity on hand, by day, by product, by location or store. Transactions, okay, I'll just explain later. Accumulating snapshots, okay, it stores the intermediate steps that has happened over a period of time. Okay, so for example, what happened with the inventory as they were received. Okay, when we got the goods receipt, we received them in their warehouse. We moved them to the stores, and it's being sold. Okay, at those different processes, what is happening technically is part of the accumulating snapshot. This is the model for the periodic snapshot. Again, we have the quantity on hand, okay, the date dimension, the store dimension, the product dimension. So when we look at the report here, we have the quantity on hand, and we can describe at what date, at what store, and which product. Okay, that's basically it. Now, inventory transactions is for those people who have attended accounting classes or finance classes, right? So we can actually translate quantity in terms of the financial value. Okay, X number of pesos worth of inventory. So that is what we will be using here. Okay, so how much inventory has been pushed on different warehouse? How much inventory have we received, or how much inventory have we sold? Okay, it could respond to the following questions. How many times have we placed a product into an inventory bin location on the same day that we pick up the product from the same bin? Okay, so it could talk about the inventory turns on that specific bin. Okay, inventory turns, how fast do we move the inventory from one place to another? Okay, how many separate shipments that we receive from a vendor, and when did we get them? Because, for example, if you order 10 boxes of eggs, 10 boxes of milk, okay, and suddenly when it came to our store, we only got 6 because that's the only amount they can fulfill. Then they gave the 4 remaining on the next day. Okay, so that's considered a separate shipment from the same order. Okay, and lastly, which products has the most number of inspections that cause us to return the product to the vendor? Okay, so before we actually stamp the receive, before we officially receive the items, these products are usually being inspected first. So let's say, oh, I will not accept these 2 remaining boxes because they have defects. Okay, it gets returned to the supplier, and then they will just come back to us again. So again, those scenarios can be captured here in the inventory transactions. Last is inventory accumulating snapshot. Okay, used in long-running continuous replenished inventory processes, provide an updated status in the product inventory. So in this case, we now have details on every step that has happened in this specific process. Okay, in this case, an inventory warehousing process. How much did we receive? How much was inspected? How much were returned? How much were placed in the bin? How much were authorized to sell? Okay, all of these steps are recorded here in the accumulating snapshot, and also their corresponding dates. Okay, when were date received, date inspected, date placed in inventory, and so on. Okay, all of these processes are inside the accumulating snapshot. Right. Dami, no? Now we will look at the last business process here. Okay. Which is the procurement process. In this case, procurement from the value chain, they handle all the purchasing or buying aspect of the organization, whether to buy for their buy ingredients for their products or buy secondary materials, your computers, your chairs, which are not directly related to production, but actually related to running the organization. Okay. That's also being handled by the procurement team. And there are 2 major domains in procurement. One is strategic and second one is operational. Strategic procurement is when they actually deal with suppliers, form into a contract so that we can leverage at discounts. Okay. That is why if you go to some companies or the industry, you would notice that you can only purchase items on specific vendors, okay, because they are leveraging a purchasing power there via a contract and discounting. Okay, bidding is also part of strategic procurement. The last one is operational, which the transactions is happening in procurement. That is when you actually request for purchase. Okay. It creates a purchase requisition document. Once it's approved by, let's say, your manager in the procurement team, it creates a purchase order document, which is then being sent to the supplier. Okay, and the supplier triggers their sales process, which creates an invoice, which is now being sent back to you for you to pay. Now, the items come in, you have the goods receipt. You will now confirm whether you got the right amount, right products, okay, using these 3 documents: goods receipt, invoice, and also the purchase order. Okay, baka naman kasi nag-order ka ng pencil and dumating ballpen. Diba? So iba pa rin yun. So you have these 3 documents. You confirm whether you got the right amount, right products, you got them at the right time, right discounting. And once it's confirmed, then you can trigger the payment process at your side. You can now pay to the supplier. Okay. Typical key measures for procurement, of course, since they are the taga-bili. Okay. Now they are concerned about cost savings. Are we purchasing at a reasonable quantity, or are we exercising our purchasing power? Okay. Now the second one is rogue or maverick spending. Basically, these are the spending that happens outside the contract. Okay, so the contracts are there to leverage on some level of purchasing power and discounting. So if you are spending outside those contracts, we might not be able to maximize our savings from that transaction. Okay, so how much was the average rogue spend on specific material? Can we look for a vendor to provide us a negotiated price? Okay, so that's what we deciding at this stage. Or maybe we can allow 10% maybe of all our purchases can be rogue spending, so it's okay. So in this case, we're checking if our purchases are still within expectations. Now, since we have vendor here, we can also look at vendor performance. Okay, how how much do they comply on what is in the contract. Okay, so this is an example of a report regarding procurement, which is procurement transaction fact. So you could imagine this is just simply our, it could be a sales fact, but in this case, we are the buyer. We are now the one buying instead of the one selling. Okay. All right. We now, for the remaining few minutes, I just want to discuss a few more things, different types of facts. And with that, I would like to discuss it using Excel. So hopefully we have enough time, 2 minutes. All right. Earlier we mentioned facts need to be additive. Okay, that means these normal or additive facts can be aggregated, can be added, or can be summarized at all dimensions. Okay, so for example, if we summarize sales amount, if we summarize it from a store perspective, from product, or from date perspective, it will still make sense. Okay, so if we go to a pivot table, okay, we have the store sales amount. Okay, the total is 290. What if we change the sales, the store to product? Okay, it's still the same. We can get the sales amount per product. If we go by date, it's still the same. Okay, so that means that the sales amount is actually an additive fact. Okay, it can be additive on all dimensions that you have in your model. So our dimensions here is date, store, and product. Okay, same with quantity sold, that also happens there. Same with margin, it's also an additive fact. We can get the margin for each date, each store, and each product. Now, we have here the quantity on hand. So basically when we sold, let's say 4 eggs, it gets deducted from the quantity on hand. So after this, we only have 6 remaining eggs. After this transaction, we only have 5 remaining eggs. Okay, so this is the quantity on hand. Now, if we try to look at it from a product perspective, quantity on hand, okay, we have 19 stocks left of bread. We have 31 stocks left of eggs. That doesn't make sense because the stock should be going down. Okay, there's an issue here. Now let's look at store. Okay, we could also use this. I'm not sure if it makes sense. Okay, from branch perspective, you can rely on how many stocks remaining in each branches. Okay, and also the product, how many stocks left are there in the entire store. But when it comes to date, it will actually show us a different level. Wait, teka lang. Mali ako. Sorry. When it comes to date, we can see here how many stocks are left on each day. Okay, so there are total 26 products on March 1, 25 products on March 2, and 14 products on March 3. Okay, that makes sense kasi bumababa yung stocks natin. We're not replenishing, but we're selling our products per day. But when it comes per store, okay, 15 total products per store. Okay, 33 products in branch B, 17 products in branch C. That doesn't make sense, okay, because it should go down. And also when it comes to the product, ganun din. Okay, in that sense, quantity on hand is additive on date dimension, but not on store and product. Okay, so when you have those kinds of facts, that means they are semi-additive facts. So those facts are not additive on all dimensions, and this is measures they record static level, such as inventory levels. Okay, inventory levels are example of a semi-additive fact. And lastly, we also have what we call the non-additive facts. They are still measures, they are still numbers, but we cannot add them very carelessly. Okay, an example is VAT or taxation. Okay, kahit anong branch yan, kahit anong date yan, they all need to be at 12%, for example. Okay, so when we try to aggregate here, let's say product and we go with VAT, okay, it's aggregating all those 12%. Okay, so that means we are producing a wrong report here. Or if you look at store, same way, it has to be 12%, pero we can see here that the tool is summing it up, and the same with date. It's also summing it up. Okay, so in this sense, these types of facts are the non-additive facts. So we got 3 facts here. We have the additive facts, the quantity sold, sales amount, margin, which are additive on all dimensions. We have quantity on hand, which is semi-additive. It is additive on some dimensions, but not all. Okay, we also have the VAT as a non-additive fact. Okay, we cannot add it carelessly on all dimensions. All right, any questions so far? All right, if there are no questions at the moment, let me just show quickly what is happening in Canvas. Sorry for the overtime. Okay, all the modules for week 3 is out. Okay, but I will upload the recording of the session as well. Okay. If you're not aware yet, I also uploaded the brief for the activity next week. Okay, which we will focus on data warehousing, and in this case, we will use SAP Data Warehouse Cloud. Okay, you can register a trial account on Data Warehouse Cloud using your OBF emails. All right, but each account can last only for 30 days. So I recommend that only 1 or 2 members of you register in case you want to have access to the tool after the 30 days. Okay, if not naman, bahala kayo. It's really up to you. How to use the SAP Data Warehouse Cloud, I also linked a tutorial playlist here, which discusses all the elements and how to use those inside the Data Warehouse Cloud. Okay, so you can have a look and feel of the tool itself. I will also record my own walkthrough of the applications, which I will upload over the weekend or until tomorrow. Okay, so in case this is not enough or baka nalabuan kayo sa place ito, I will also upload my own walkthrough. Okay, what needs to be done? Okay, from the metrics that you presented last week, okay, during the product presentation, you will simply choose one KPI to focus on. Okay, so you have presented maybe more than one. Okay, just focus on one para tapos na tayo sa ita-track natin. Or if you were not able to present a KPI, then you would have to do extra work. You need to identify what KPI do you want to track. And again, on top of that, you will also come up with categorical dimensions. Okay, so after you identify what KPI to track, okay, you need to think of what dimensions do you want to include. Okay, earlier part of the dimensional modeling process is identifying dimensions, right? So that's basically it. Identify your dimensions. Time dimension is required. Okay, categorical dimensions must be able to address potential questions that the metric has to answer. So if we're looking at profitability as one of the KPIs, then we want to look at profitability per brand, per product category, profitability trend for a year. Okay, so those things. For example, if your KPI is to increase revenue, a marketing person would want to look at seasonality or time and product hierarchies to know which product categories and specific items need to be promoted and when. Okay, if your goal is to retain customers, then think of what dimensions do we need to include so that we are not just looking at the number, and we can actually get more insights on the figures. Okay, so now once you come up with these two, basically what you're doing is you will come up with your own dimensional model, and using that model, you will either look for data that corresponds to that, or you can also create your own data. Okay, using Mockaroo or Mockup data. Okay, this is not a class on looking for data. So it's really up to you on how you will come up with your data. Whether you find one or you make one, that's fine with me. Okay. the task here is actually to model that data and also to create the dimensional model. And later on, we will create the report also in the data warehouse cloud. Okay, so you will upload the schema in the data warehouse cloud and create a dashboard. This is the final output. Okay. Now, next week, sir, do we have class like this? Okay, I'm canceling the classes next week. What we will do is that for the entire week, I will open, so I will accommodate consultation sessions per group. Okay, so the goal for that is in that 1 hour, we will try to think of a dimensional model for your KPI. Okay, so we will just sit down and work on it together so that you're not lost in the process. That's it. That's what we will do. The deadline of this one will not be next week because I think there's too much work needs to be done here. So next week is just purely for consultation and for you to work on this to understand what's really happening in the data warehouse. All right. Are there any questions before we end the call? We're 10 minutes overtime. Maybe one question also is that we have a checkup quiz, which is by group. Okay, so data warehousing concepts that falls under 3-4. Yeah, 3-4. Okay. Please just upload please one member lang per group ang magsasubmit ng answers. Okay? So not everyone in the group should submit, just one person per group. Okay, so it's up to you on how you will manage it. Okay, as long as the grading for this checkup quiz will be by group. Okay, so work on it together kasi there could be so much stuff in here and you would want to split it on your groups, on your group mates. Okay, any questions? Yun lang naman yung dalawang points that I want to raise. Also, for those people who weren't able to upload their project presentation materials last week, please do so on the business idea pitch. Hopefully by today, you can upload them, your presentation materials, or link to a Google Drive if you presented a lot of things, videos, presentation, and so on. Okay, this is simply for documentation process purposes pala. Okay, napaka-process ng process. This is simply for documentation purposes. All right. Okay, if there are no questions, okay, you are free to reach out to me via Canvas inbox or email. But for now, if you have no questions pending, I'll see you guys next week on your consultation sessions. All right. Thank you so much. Have a good lunch.
Thank you, sir.
Thank you, sir.
All right.
Sir, I was going to ask you pala for
yes.
For the presentations, can we still add slides to our PowerPoint?
Not anymore for that one, but maybe we can talk about that during the consultation.
Okay.
For next week. Yeah. Because this is simply for you have grades already for the presentation. So this is just for documentation purposes.
Okay, sir. Thank you.
Okay. All right. See you next week.